So hello guys, I'd like to continue with our question 1 into 1.2 and 1.3. Now in 1.2 we're solving an equation simultaneously, and when you want to solve equations simultaneously in grade 11 and grade 12, you'll be given mostly a type of a quadratic equation and a linear equation. So in this question we have x squared minus xy minus 5y squared equals to negative 5, and we'd like to label the first equation being the one that you're given on your left hand side. So this will be equation 1, and the second equation is x plus 2y equals to 1, and that will be our second equation. Now since you want to solve simultaneously, in equation 1 you are having two variables, which is x and y, and those two variables are having the second order, which means they are squares. Now you want to use the simplest equation, of which comes from equation 2, that is equation of first degree, but you must try and make or look for the simplest variable, most likely the one with the coefficient of 1, of which here it's x. So we'd like to make x the subject of the formula for equation 2 that gives us our third equation. So here we'll say x is equals to 1 minus 2y, and that's our third equation. Then after getting the third equation, you will then say substitute equation 3 in equation 1. Then I like to first rewrite the whole equation. Xy minus 5y squared is equals to negative 5, and since we said x is equals to 1 minus 2y squared, then we have to substitute that 1 minus 2y squared. That's not proper 2. Minus y into 1 minus 2y minus 5y squared equals to negative 5. Now substitution gives you a mark, and then creating the third equation gives you another mark. Then when we expand this, we will get something like 1 minus 2y minus 2y plus 4y squared minus y plus 2y squared minus 5y squared equals to negative 5. Negative 5 here. Okay, yeah, that's a negative 5. And then we then group like terms in order to get a proper sum. So you'll start with it's either you rearrange, you just start summing up from this equation. For example, I already see that I can start summing up 4 plus 2 is 6, minus 5 will give me a y squared, and then if I say minus 2 and minus y, it gives me a minus 5, and if I say 1 and I take the negative 5 to the other side, then it will become a positive 5, so it's 1 plus 5 and it gives me 6. So I will then do the grouping of like terms just for simplicity. So this will be I'll start with 4y squared plus 2y squared minus 5y squared. Then I'm done with the ones of second degree, which is the ones that contain a square, and then it's a minus 2y minus 2y and a minus y. Then I deal with the ones that don't have any variables, so it's a plus 1 and a plus 5 equals 0. Then now we can sum up. 4 plus 2 minus 5 will give us y squared, minus 2 minus 2 minus y will give us a minus 5y, and that will give us a 6 plus 6 is equal to 0. This can be easily factorized. Can open two brackets, and you have y and y. The factors of 6 that will give us 5 are 3 and 2. 3 and 2, and they have to be both negative. And then now you solve using the, as we said in the first 1.1.1 to 1.1.4, we solve using the 0 law. So y minus 3 is equal to 0, or y minus 2 is equal to 0. Then y is equal to 3, or y is equal to 2. Now we were solving simultaneously, so that means we have to get both variables of x and y. We've gotten y, so we go back to our equation that says x is equal to 1 minus 2y. And you say when y is equal to 3, what is my value of x? So x will become 1 minus 2 times 3, which is equal to 1 minus 6. And 1 minus 6 is negative 5. And when y is equal to 2, my x value will be equal to 1 minus 2 times 2, and you get that x is equal to 1 minus 4, which gives us negative 3. Then you have simply solved both variables x and y simultaneously. And let's try and now do quickly 1.3. In 1.3, you say determine the values of t for which the equation 5 to the power of x is equal to 2 minus t will have real solutions. Now, when we talk of real solutions, we talk of the discriminant being greater than 0. Now, we've been given this equation that says 5 to the power of x is equal to 2 minus t. Now, this means it's either 5 to the power of x that is having real solutions and is greater than 0 as our discriminant. Why? This equation can already be taken to a quadratic equation. If you are going to say it's 5, or if you square both sides here, let me just show you. If we were to say we are squaring both sides here, and we are squaring both sides here, we would get something like 5 to the power of 2x. So that equation is already a quadratic. So that's why we can talk of the discriminant. I want to reverse this. And let's just erase. Okay. So this means from the main equation that says 5 to the power of x is equal to 2 minus t. If this is a discriminant, then it means now 2 minus t, because they are both equal, 5 to the power of x and 2 minus t, they are both equal, is greater than 0. And that means if we take t to the other side, it becomes a 2 less than t, of which it means all the values that are less than 2 will give us real solution. Now, if you want to test that, you can test with saying 5 to the power of negative 1 is greater than 0. And that is true because 1 over 5 is greater than 0. 5 to the power of negative of positive 1, also 5 to the power of positive 1, because 1 is less than 2, will be sorry that I had a wrong sign here, will be greater than 0, because that's 5 being greater than 0. Right, then we're done with question 1, and please post your questions in the comment section and we shall attend to them. We'll be back with question 2, 3, and 4. Thank you.